This video is in our graphing module, and this first one is general information on the rectangular coordinate system. So we're going to do some labeling and defining on this first graph that you see at the top. Actually, this is called a rectangular coordinate plane. Let me write that here. Or sometimes it's just abbreviated as a coordinate plane. And I'm going to get a darker marker because I don't think that one's going to show. The plane is made of two axes. We have the x-axis, which goes horizontally. We have the y-axis, which is our vertical axis. And those two axes cross right here at this point at an intersection that is called the origin. And what you can think of is you can think of the x-axis as a number line with negative numbers up to 0 and then positive numbers to the right, and the y-axis is like a thermometer sort of with 0 and then positive temperatures, 0, negative temperatures. And again, where they intersect right there, that is called the origin. Every location on the coordinate plane can be described by what we call an ordered pair. It's called order because the order of the numbers matters. The x coordinate is always given first. So for example, if I wanted to find, as an example, the location 4, 5, since that 4 comes first, that means it's in the x direction, and since it's positive, it means it's to the right, so I go over 4, I do not make a dot yet, and then the 5 is the y point, and since it's positive, it means to go up 1, 2, 3, 4, 5, and right there is the location 4, 5. So I sort of touched on this, but let's talk about positive direction versus negative direction. So when you are traveling from the origin on the coordinate plane, the positive directions are right and up. The negative directions then, obviously, are the opposites. So it would be left and down. Also, when the two axes split this plane, it splits it into 1, 2, 3, 4 what we call quadrants. And those quadrants are numbered, and it matters how they're numbered. They're numbered with Roman numerals. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. You can remember that if you get confused about where the first one is by thinking of a clock. And let me get this labeled and I'll show you what I mean. 1 o'clock on the clock is in the upper right quadrant. Let me divide this. If I split my clock into 4 pieces, you can see 1 o'clock is in the upper right quadrant, and it's the same thing with the coordinate plane. Quadrant 1 is in the upper right section. 11 o'clock is right here, and if I take that 11 and I put lines on it, it makes a 2 in Roman numerals. That's kind of a stretch, but there you go. The third one doesn't fit with the clock scenario, but the fourth one does. This is 4 in Roman numerals, and look where the 4 is, lower right. So that might help you if you needed to label those. As you travel, if I wanted to get somewhere into quadrant 1, I would have to go right and up. Well, right is a positive direction, up is a positive direction, so that's a positive quadrant. If I wanted to get into quadrant 2, I would have to go left. Remember, you go left or right first and then up and down. So I'd have to go left, which is a negative direction, and then up, which would put me somewhere up here. So that is a negative positive quadrant. If I want to get somewhere down here in quadrant 3, I'm required to go left, which is negative, and down, which is negative. So that's a negative quadrant. And if I want to get to quadrant 4, I travel right and then down. So that is a positive negative quadrant. All right, so let's practice plotting points. When you locate a point on a coordinate plane, it's called plotting, and we're going to state the quadrant. So point A is the point 5, 3. Remember, it's always X and then Y. So this says go positive 5, which means to the right 5. So here I am 5, and then go up 1, 2, 3. So there is point A, and it is in quadrant 1. Point B is -2, -4. So I start at the origin and I go left 2 and then down 4. So here is point B, and as you can see, it is in quadrant 3. The point 1, -2 says go right 1, down 2. So there is point C, and it is in quadrant 4. -5, 3 says go left 5, but then up 1, 2, 3. So there is point D. It is in quadrant 2. Now we have 0, 0. Well, we know where that is. That's the origin. So it's not in a quadrant. It's just the origin. These two I want you to be real careful of. They're easy to get backwards. But the point 0, 2 says 0, X, don't go anywhere in the X direction, so I stay put. And then the 2 says Y direction, go up 2. So there is the point 0, 2. That is point F, by the way, that was E. And that is also not in a quadrant. That is on the Y axis. -5, 0 says go left 5, that's the -5, and then this 0 says but do not go up or down. So there is point G. It is not in a quadrant. It is on the x-axis. Now I put these two on here. You're not going to see much of this, but just to show you that you really can plot fractions too. It's not very convenient, but you can. 0 means don't go left or right. -5.5 says go down 1, 2, 3, 4, 5, and halfway to 6. So right there is point H. It is on the y-axis. And finally, the point 4 2/3 and -3 is telling us to go right 4 and almost to 5. That's 2/3, and then down 1, 2, 3. So here is my point I, and that is in quadrant 4. All right, continuing on, let's look at the next thing we want to talk about with ordered pairs and coordinate graphing, and that is completing ordered pair solutions. So this is a real important concept. In general, an ordered pair is a solution of an equation that has two variables if, when you replace the variables by the values of the ordered pair, you get a true statement. Now, what exactly does that mean? Well, we're going to look at that in just a second. So let's consider this. When we had equations like 3x plus 4 equals 13, there's an x there, and there's no y, and the x isn't squared. It had exactly one solution. Later in the course, you're going to look at equations like x squared minus 25 equals 0. So that it still only has an x, but it's squared. That has exactly two solutions. But when you have an equation like 3x plus y equals 12, so you have both an x and a y, those equations have infinite solutions. And that doesn't mean you can just pick anything you want and it's going to work. There's an infinite number of solutions, which you're going to see why in just a second. But they are specific what they are. So let's look at an example. So example 2 says complete each ordered pair so that it is a solution to the equation 3x plus y equals 12. And as you will see, I have ordered pairs started but not finished. So this one says take a 0 and put it into the x spot. It's in the x position. So I go to my equation, 3x, I take out the x, I put in a 0, plus y equals 12. But 3 times 0 is just 0. And so I end up with y equals 12. And what that means is, in that equation, to keep it true, if x is 0, y has to be 12. So that's one solution. Let's look at another one. This one also has a 0, but look where it is. It's in the y position. So I go back to my equation. I write 3x plus, take out the y, put in my 0, equals 12. That's just a 0. So 3x equals 12. I divide by 3, and I get x equals 4, which means if x is 4 and y is 0, and I plug them back in, it will still be true. So there's another solution. Here is another one. This one is telling me to put a 2 into the x spot. So I go back to my equation, 3, take out the x, put in a 2, plus y equals 12. 6 plus y equals 12. I solve for y I do like any equation, and I get y equals 6. That's another solution to that equation. And I could keep doing that all day by picking either an x or a y and then solving for the other one. Now what I want you to see is what happens when we plot those solutions on a coordinate plane. So the first one is the point 0, 12, which is actually up here. The point 4, 0, so go 4 and then don't go up or down. And then the point 2, 1, 2, 3, 4, 5, 6. Now let me grab a ruler and let's see if we can draw to connect those points. And you're going to see what happens when you plot the solutions of what we call linear equation. Look what happened. They all lined up. And that's exactly what is supposed to happen. If they had not lined up, then we would have been known that we had made a mistake on one of our solutions. So the solutions of a linear equation should always make that straight line. So it says, what do you see? A straight line. Always, no exceptions. All right, let's try another one where it's set up a little bit differently. It says complete the table for the equation y equals 3x, and then graph. Graph means to plot all the points and connect them. And rather than having ordered pairs like I did up here, started but unfinished, I have a table where I have x values and y values that you're going to put in. So the first one says put a -1 in for the x. So that would be y equals 3, take out the x, put in a -1, or y equals -3. So I took my equation, I used what I was given, and I plugged it into the appropriate spot in this case and solved for the other variable. So now I have the point -1, -3. So -1, -1, 2, 3. There is my first point. Next I go to the 0. Where does it go? It goes in the y spot, back in the original equation. So the equation was y equals 3x. I take out the y, I put in a 0 equals 3x. We divide by 3, and we get x equals 0. So it says when y is 0, x is 2. Well, we know where that is. That's the origin. Finally, it tells me to put a -9 in the y spot. So -9 equals 3x. Remember, every single time I'm going back to that equation. I solve that by dividing by 3, and I get x equals -3. So I have the point -3, -1, 2, 3, -9. Once again, if I take the 3 points that I plotted and I connect them, I have now graphed not only my solutions, but I have graphed the equation. That's the language that we use. We have graphed that equation. Let's do another one of those, of graphing an equation by plotting points. This one you're going to see we have a fraction in it. Now that can be good or it can be bad. You're going to learn in another section that you have control over that. This time you don't have control, I have control. So let's look at our XY table. That's what this is called. The first time it says put negative 2 in for the x. So we're going to go up here and say y equals 1/2. Take out that x, put in a negative 2. I'm going to put it over 1. And then minus 5. Well, those cross cancel. So what I have is y equals 1 times, remember there was a negative there, negative 1 is negative 1 minus 5 is negative 6. So I have my first solution, negative 2, negative 6. So negative 2, let me see down here, negative 6, right there is my first point. Next, it's telling me to put a 0 into the x spot. So that would be y equals 1/2 times 0 minus 5. We like this because anything times 0 is just 0, and you end up with y equals negative 5. You're going to learn that in graphing, 0 is your best friend. So 0 down to negative 5, which is right there. Lastly, and a little bit harder, we're going to put a 0 into the y spot. So that would be 0 equals 1/2 x minus 5. Now what I am going to do is add a 5 first to both sides. And I'm going to get 5 equals 1/2 x. Now how do I get rid of that 1/2, the fraction? I multiply by the LCD. So I must do the same thing on this other side. And I end up with 10 equals x. So when y is 0, x is 10. So I have the point 10, 0. Now be careful, even though we have the 0 first, the point is the point 10, 0, not 0, 10. We just found the x part. Connecting them, I can see that, yeah, they all line up. Therefore, I must have plotted them correctly and found the solutions correctly, and there is the graph of our equation that we were given right here. All right, let's look at a real-world application for graphing. Number 5 says a small business purchased a computer for $2,000. The business predicts that the computer will be used for 5 years, and the value in dollars, which we're going to call y, of the computer in X number of years is this equation. Y equals negative 300x plus 2,000. Complete the table. Now this may look confusing, but it's actually the same thing that we've been doing the whole time. It's just rather than having an XY table that's vertical like this one is horizontal. So it's saying x is 0. Okay, we can put a 0 in for x. Y equals negative 300 times 0 plus 2,000. That just makes a 0. Y is 2,000. X is 1. Okay, y equals negative 300 times x plus 2,000, or y equals negative 300 plus 2,000, which is 1,700. Next, x is 2. Okay, y equals negative 300 times 2 plus 2,000. You see what I'm doing? Each time I'm putting the x value into the equation right there in the x spot. So y equals negative 600 plus 2,000, or y equals 1,400. Now hopefully some of you have noticed a pattern here, and I don't need to finish these, I can just fill it in. Notice that every year, remember the x's represent year, the computer value goes down by how much? It goes down by 300. So this one should be 1,100, 800, and 500. Now this is fantasy land because I promise you at the end of 5 years your computer is not worth $500, but whatever. So what's happening is the initial value was 2,000. So when it was 0 time, the computer was worth $2,000. That's our first point, 0, 2,000. Then we have 1 at year 1. It's worth 1,700, right in between there. Then at year 2, it's worth 1,400. At year 3, it's worth 1,100, which is about right there. At year 4, it's only worth 800, and at year 5, it's worth 500. Ha ha. So if we connect these, you will see that there is a steady decline in the value of that computer. Notice, by the way, when I graph, I put arrows on the end to show that it continues to go in both directions. There's a steady decline, and my equation actually said that. It says the value that we call y goes down $300 every year if you start at 2,000. That's what that equation actually means.